Uh, Good morning, guys. Once again, in session number 2 of chapter Surface Chemistry, desorption process. Desorption process is reverse of adsorption. It means in adsorption, the particles get adsorbed or concentrated on the surface, and in desorption, the particle gets removed. So desorption process is directly proportional to temperature. As the temperature increases, desorption process also increases. So next is absorption. So I am here showing you the comparative study between the absorption and adsorption. Absorption is the process as a result of which species of one substance get distributed uniformly through the bulk of other substance. Okay, means all the particle uniformly penetrate deep in the bulk of other substance. That is why this is called bulk phenomenon. An absorption process occurs at uniform rate, but in adsorption the process is the process as a result of which species of one substance get mainly concentrated on the surface of other substance. It is a surface phenomenon. It is very rapid in the beginning, but as the surface starts getting covered by the particles of other substance, then it becomes slow. And next is sorption. When the process of adsorption and absorption takes place simultaneously, this is called sorption. Example I have already given you: when the piece of chalk is rolled on the ink, then both the processes takes place. Next is very important conceptual topic: thermodynamic feasibility of adsorption. Means to say, adsorption process is spontaneous in nature and we have to justify. So question is asked by the CBSE: justify that adsorption is a spontaneous process. Now we all have studied in class 11th that for a process to be spontaneous, delta G should be negative, and delta G is equal to delta H minus T delta S. Delta G is gives free energy, delta H is change in enthalpy, and T is temperature, and delta S is the sign of change of entropy. Now we are also aware of the fact that during the adsorption, randomness of substance particles decreases and it gets sticked or concentrated on the surface of adsorbent. That is why the randomness decreases, means sign of S should be negative. And we also know that during adsorption, the adsorbate particles get sticked and it form bond with the surface of adsorbent. And when the bond formation occurs between adsorbate and adsorbent, so it result into decrease in energy. That is why the sign should become negative. Okay, now the thing is, since the process is spontaneous, so delta G must be negative, and delta G will be negative only when delta H is more negative as compared to T delta S value. Okay, here in the notes it is written, you see, delta H favors the adsorption, but T delta S opposes the process of adsorption. So it is feasible at low temperature only. I hope you are getting why the delta H favors, because sign is negative. If delta H is more negative, then sign of delta G will be negative. Okay, and T delta S sign is positive because T is negative and delta S is negative, and negative becomes positive. So it means to say, if the temperature is more, then what happens? Then if the temperature is more, then the T delta S value becomes more and it will become more positive, and it can decrease the spontaneity of process. Got it? Because delta G will become less negative if the temperature is more. Now when the adsorption process proceeds, delta H becomes less and less negative, and finally delta H becomes equal to T delta S. And when delta H and T delta S becomes equal, then the delta G value will become 0. And when delta G value becomes 0, then the equilibrium state is attained. Okay, I mean to say adsorption is very fast in the beginning, but afterwards when all the surface of the adsorbent get covered by the particles, atoms and molecules, then equilibrium state is attained and adsorption decreases to greater extent. Thank you.